In a game similar to Call of Duty this time, mortar is a kind of a very powerful cannon, shoots a bomb and hits a target at the distance of d equals 870 meters. Oh, that's quite likely we will have very similar, no, because we have 60 degrees of angle. All right, so it's just a coincidence that this is the same distance we had in the previous one. So we have this mortar here, and sorry, what happened? I have no idea. Okay, we have this mortar here. It throws a bomb like this. Okay, but this time we know this distance here, and this distance is d equals 870 meters. What is the maximum height? So we will again need to find the maximum height. But this exercise is going the other way around, because the second question is height of the bomb during the flight. And what is its velocity there? Oh, velocity there. So what is this velocity here at this moment? So that's the velocity they are asking for in this exercise. Okay, so yeah, let's have a look what we get here. So we have to find velocity at the highest point and the height or altitude at this point, of course. But it will start the same as previously. So with the initial velocity, which is not given, and they are sorry, that's which is what happens. Everything disappears now. I must have sorry, I will erase this because that's terrible. Okay, and back to the pen, and I will also change the color to red. Sorry, red. So as previously, we have the initial velocity, which can be decomposed. What is that? I have activated some strange mode in PowerPoint, probably. So that's the horizontal velocity. Sorry, it should be horizontal. It's not exactly horizontal, but it really should be. And that's the vertical velocity. And of course, I can write, even without thinking too much about it, that Vx, the horizontal velocity, it's V cosine alpha, and the vertical velocity is V sine alpha. Okay, standard calculations. I can go even a step further. Cosine alpha from here is 0.50. So it's 0.5 V, whatever V is, and Vy is sine alpha. Sine alpha is 0.87, so 0.87 V. One more thing to notice is that this velocity they are asking for is in fact the Vx. So this is Vx they are asking for. So we need to find h and vx. Why vx? Because at the highest point, the vertical movement is for the moment stopped. Okay, we've been accelerating from the very bottom to the very top. Okay, then the cannonball is for a moment not moving up, not moving down, and then it will start travel back to the earth. But the horizontal direction, in the horizontal direction, this movement is all the time the constant speed. So at this highest position, the vertical speed component is 0. The horizontal speed component is 0.5 v. So as soon as we find v, we will have the solution for this part. Okay, so let's try to do it in a similar way as previously. So half of the time I will change the color to black, maybe. Or I call it previously not ascend, but half of the time. Okay, so as we did it, as we made it last time, it's the vertical initial velocity divided by the gravitational acceleration. From the formula for the velocity in accelerated movement, acceleration is g. The component of the velocity affected by the gravitational acceleration is only the vertical, so Vy. Therefore, what we have here is Vy is 0.87 V divided by 10. So we have 0.087 V. That's our half of the time. Now the entire time, the double time of the flight is twice this value. V. Don't forget that this is V. We don't know the value in seconds. We only can know at this stage, we can see the relation between the initial velocity of the cannon, and the initial velocity is this, so working in the diagonal direction, okay? And the total time. So this total time is this times 2, it's 0.174 V. All right. And now, again, an analogic way to the previous exercise. The previous exercise was easier because we could go from the beginning to the end. Now it's like the opposite direction. So from the results we got last time to the source data, input data, but it's algebra, okay? So last time we have found the distance, and this time we know this distance, so still we can put it like this. Distance is Vx t. All right, Vx t. Vx is this thing, and time is this thing. So I can substitute whatever we know about it. Vx is 0.5 v multiplied by time. It is 0.174 v. So this is 0.5 times 0.174. It's again 0.087, but be careful, it's v times v. So we have v squared in this case. 0.087 v squared. But one more thing, we know that the distance traveled is actually 870 meters, and this is the formula for distance. So I can tell that whatever we have here, this is 870. From this, I can now find that v squared equals 870 over 0.087, and this, you can use a calculator for this. This is 10,000. Okay, 10,000, that's v squared. So v without the square in it will be a square root of 10,000, and square root of 10,000 is 100. Actually the same velocity we had the last time. So velocity is 100. Therefore, we can go back here and say that Vx is 0.5 times 100. It's 50 meters per second. And we can also say that the vertical speed is 87 meters per second, okay? So a lot of things have already explained. And now one thing, nice thing is that what they were asking for was actually the Vx. Therefore, my first answer is here. Okay. So just to resume on this, the bomb was shot with the initial velocity like this one, 100 meters per second. Should be written black, never mind. So it's 100 meters per second. Then the horizontal component of this velocity was 50 meters per second, and it was applied all the time because the horizontal velocity never changes. There is no force working in the horizontal direction apart from the aerodynamic drag that we ignore. And the vertical component was 87 meters per second, but at the highest position of this flight, the vertical component dropped to zero, therefore the total velocity at this highest point is 50 meters per second, and this is the answer for this question. Now, what is the maximum height of the bomb? This is calculated exactly using the same mass, the same formula as in the previous exercise. I will change the color to blue. We'll draw a big fat line here, and I will finish my calculations here. So the height can be found from the accelerated motion formula for distance, and this is acceleration at squared over 2. Acceleration, which in our case is the gravitational acceleration g, times half time. Okay, it's again only the half of the time that it has to go up and another half of the time to go down. So this is half of the time squared over 2. So it is, I'll continue here, 10 times half of the time, it is 0.087 V. So 0.087 times V, we now know that this is 100, okay? And this has to be divided by 2. So I have 10 times 0.87, this is 0.87. Sorry, wrong. It is, I've forgotten a very important thing. This is our time, and this has to be squared. Okay. All right. I was quite close to make a stupid, really stupid mistake. So this is the gravitational acceleration. This is time taken from this formula. Okay. So this is simply 10 times 0.087 times 10, it is 0.87 squared over 2, and because my spaces are nearly gone, I will just continue on the calculator, and the result of this is 378.45 meters. That's the maximum height at which we have wrong. I will apply eraser once again. I wanted to finish quickly, and of course it's 100 here. I thought it was 10, okay? but the time is 100. 0.087 times 100, it's 8.7. Okay, this times this. 8.7 squared over 2. And this, after calculating this result on a calculator, it's 378.45 meters. So that's the final thing. This is square. Okay, doesn't look like this, but all right. 10 times 8.7 squared over 2, it's 378.45 meters. That's the final distance. It's 5 to 11.